This video explains what model binding is, how it works, and how to customize its behavior. Model binding is a mechanism that automatically maps data from various parts of HTTP requests, such as query string, form submissions, or JSON payloads, to the corresponding model objects in the application. Imagine the complexity of each time manually parsing and extracting the HTTP request to gather the essential data in our action methods. Model binding eliminates this need for manual extraction and conversion of the data, thus making our code more concise and maintainable. The parts of HTTP request from where we get the data to bind are called sources. The properties or parameters to which these values are bound are called as targets. In this video, we will dive into the fascinating world of sources and targets. There are two types of target that model binding tries to bind to. First one is more obvious one, the parameters of the controller action method or the razor pages handler method that a request is routed to. The second one is not so obvious one. Those are the public properties of a controller or a page model class. But we need to specify that with an attribute. To bind a public property of a controller or a page model class, we can use the bind property method as shown here. To bind all properties of a page model class or a controller class, we need to use the bind properties method on the controller class itself. By default, these public properties are not bound during a HTTP GET requests. To enable it, we need to set the suppress GET property to true as shown here. Targets can be classified into simple types and complex types. Types that can be built from only one input value are called as simple types. Types that require multiple input values to build are called complex types. Let us see this with an example. Imagine you have an API with a slash date route just like this. It takes a parameter of type custom date time, which is a custom class defined over here. Based on the need, you might want this API to be invoked like this and expect the model binder to convert datetime query string into the custom datetime class. If this is what is required, then custom datetime is a simple type as it just requires only one input value, which is the datetime query string, to build this class. But if you want the API to be like this, where you have two query strings, date str and time str, which matches the public properties of the custom class. In that case, this custom datetime will be a complex type as it now requires two input values, date str and time str, to build this type. Does that mean based on how API is invoked, the target type is determined to be simple or complex type? No, model binder determines the type based on some assumptions. So if it determines this custom datetime as a simple type, then the API can be invoked only this way, only using this way. If the model binder determines if custom datetime is a complex type, then the API can be invoked using this way. Let us see what assumptions model binder make with the help of this flowchart. First, model binder sees if the target type has a type converter or a try pass method. In our example, it checks if the custom datetime class has these methods. If so, it uses that method by passing a single input value matching the property name and the parameter name of the action method. In this case, the request should be sent something like this. In our case, custom datetime class doesn't have any of this method, and so a request sent like this will result in an exception. If the type doesn't have a type converter or a try pass method, then it checks if it has a public constructor and also public writable properties. If it has both, then it is determined as a complex type, and multiple values will be used to build that custom type. In our example, the API request should be something like this, where the query string values keys matches with the property names of the custom type. If none of the above condition are satisfied, then model binder throws an exception. Now let us see about sources. Value providers provide the model binder the necessary data in the form of key value pairs. The default value providers fetches values from the following sources in the order specified below. First, the form fields, then the request body if the controller is decorated with the API controller attribute, then it scans the route data, then the query string parameters, and finally the uploaded files. But there are some exceptions here though. Those are route data and query string values are used only for simple types, and uploaded files are bound only to target types that implement iForm file and IEnumerable form file. But what if you want to change this order? Let us see that in the next slide. We have some attributes that can be used to override the default bind order: from query, from route, from form, from body, and from header or those attributes. These attributes can be added to the action method parameters and public properties of the controller. They can be added to model properties individually and not to the model class. In our example, the from query attribute has to be applied to the properties of the custom datetime but not to the custom datetime class itself. These attributes can be added to the parameter of the action method, something like this. But what if the form field name is different from the parameter name? To support this, these attributes optionally accept a model name value in the constructor. So the form field name is date-time and the action method parameter is datetime without a hyphen. Then we can use this overloaded constructor to specify the form field name to be used. The from body attribute has some limitations which is worth mentioning here. The ASP.NET Core Runtime delegates the responsibility of reading the body to input formatters. These input formatters have some limitations. It can read only the body and don't understand other binding source attributes. And the second one is it can read the request stream only once, as the stream will no longer be available after the first read. Because of this, there are some restrictions in using from body attribute. First, when from body attribute is used with a complex type parameter like here, it disregards any binding source attributes applied to its properties. Like here in the custom datetime, we have used from query in both the public properties, but those will be disregarded. And the second one is when applying from body to more than one parameter per action method, as shown here, the additional parameters will not be bound correctly. That is because the stream can be read only once and then it will not be available to read again. Let us recap what we have seen so far. We have seen what is model binding and its advantages, what is a target, different targets like public properties of controller, parameters of action methods, and what are simple types and complex types. Then we went on to look into sources, what is the default bind order, customizing bind order using different attributes, and limitations of from body attribute. In the next video, we will dive deeper into advanced topics. We will uncover the magic behind custom model binders, explore techniques for adding input formatters, and venture into the manual model binding for fine-grained control. Please don't forget to hit that subscribe button and ring the notification bell so you won't miss the next part of our ASP.NET model binding journey. Thanks for watching and I will see you in the next video.